Start. Yeah. So welcome to hydraulics laboratory. Okay. So there are different experiments that we are going to conduct on motors, pumps and turbines, particularly in hydraulics laboratory. Okay. So basically first we'll study from the different types of instruments that are used to calculate, that are used to find out the discharge. Okay. Among those, the first and most important and mostly used experiment is determination of coefficient of discharge using venturimeter, right? So venturimeter is a device which is used to find out the discharge that is flowing through a pipe. Okay, basically we will attach the whole setup of this venturimeter to any pipe whose discharge is to be measured. Okay, so typically the venturimeter setup has venturimeter setup that we are having in our experiment in our laboratory is its diameter is 25 mm and it is reduced to 13.5 meters gradually, 13.5 millimeters gradually, again it is brought to its original diameter, that is 25 millimeters, right? This is a typical setup of venturimeter. Okay, so basically before going to the actual experiment, we'll understand the basic importance of finding the coefficient of discharge. Okay, coefficient of discharge, it indicates the efficiency of that particular pipe. You can say that it means it will measure along with the losses. If you find out the CD values, we can estimate the amount of losses that is happening in the particular flow. Okay, so CD is calculated as Q actual to the Q theoretical. It is the ratio between actual discharge to the theoretical velocity, theoretical discharge, right? Theoretically, imagine you are having 100 liters per second. Okay, but in actual discharge won't be 100 liters per second. There are few losses because the flow is passing through the pipe. There are frictional losses, there are minor losses and different types of losses. Due to these losses, the energy will reduce and actually we won't get 100 liters per second. We will be getting some X liters per second which is less than 100 liters per second. Okay, so that X percentage depends upon the coefficient of discharge of that particular flow, right? So that is what we are going to find using venturimeter. Okay, CD can be also found using orifice meter also. We will discuss about orifice meter in detail in the next videos. Okay, so this is a typical understanding of venturimeter. Basically it is just used to find out the discharge through the flow. Okay, we will put the setup for whose on a pipe whose discharge is to be measured and we will calculate the required values, and that is how we calculate the CD value. Okay, Q actual is found out by using this relation volume by time. So we will measure the time for a required amount or for a noted amount of volume. That is how we get the actual discharge. And Q theoretical can be found by using this formula. Basically discharge is nothing but area into velocity. Okay, the area is not the uniform area here. We are reducing the area. With respect to that, I have written this reduced area. Okay, so and V is, how can we calculate V? V is nothing but square root of 2GH. Okay, this is the theoretical discharge and we know the actual discharge. By putting these values Q actual by Q theoretical, we will get the CD values, right? So basically venturimeter has very good efficiency. The efficiency of venturimeter is more than 0.95 to 0.9697%. 97 is also possible in some cases. Okay, so we have seen the importance and what is the procedure for doing that. So now we will calculate the actual experiment. So we have seen the importance of finding CD using venturimeter. So we will see the setup, right? So we have a reservoir here, okay, and we have a collecting tank and we have motor supply here. From this we will get the water from this using this pipe. Okay, and see, this is the arrangement for Venturi as I have explained in the video earlier. Okay, there is a gradual decrease in diameter and again it will come to its original position. Okay, so because we are changing the diameter from D1 to D2, there is a loss of energy, right? There is a head loss. Okay, that head loss can be found using these pressure gauges. Okay, using these pressure gauges we can find the head losses, and this should be open because we are doing for venturimeter, and orifice meter wall should be closed. Okay, we have opened the wall for venturimeter and this is collecting tank. It is gradually measured. We can measure the depth we can take for 10 centimeters and we can note the reading, and we know the area of the collecting tank. The area of the collecting tank is 25 into 25 centimeter squares, okay, and the dia of the pipe is 25 mm, okay, and the dia of the venturi throat is 13 millimeters. So using these values we can calculate A1, A2, and also we can calculate V, right? So the thing which we need is, we need head loss, okay, the difference in head from this point to this point, and we need the time that is taken to rise for 10 centimeters, okay. So we'll perform the test now. Okay, this is actually used to remove the air valve that is present, air bubbles that is present in the pipe, okay. So right now you can see the H1 reading is, this is 0.5, 0.678 and 0.85. H1 is 0.85 kg per centimeter squares, and H2 is okay, H2 value is 0.6 kg per centimeter squares, okay. Now we'll take the reading for 10 centimeters. Now we'll take the reading for 10 centimeters. Okay, so we have taken the reading for 10 centimeter rise, and we have also noted the head difference that is present at this point and at the throat, okay. So we have taken the values and we will do the calculations now. So we have noted the values, okay. We have noted H1, H2, okay. The values which we have taken is in kg per centimeter square, but we have to substitute here we have to substitute in meters of H2O, right? So we need to convert this kg per centimeters into meters of H2O. So in order to convert from kg per centimeter square, kg centimeter squares to meters of H2O, we need to multiply with 10.33, okay? So that we will get the head in meters of H2O, head loss in meters of H2O, right? So here we can see we have noted the time that is taken to rise 10 centimeter height, okay. We have performed 2 tests, okay, and we have noted the individual timings, and we can calculate actual discharge using this formula, okay. Here we can see we know the area of the tank, and we have taken the standard rise or standard depth, that is 10 centimeter, and we have also noted the time that is taken to rise this 10 centimeters, okay. In first case the time was around 4.03 seconds, okay. So using this formula we will get the actual discharge, okay. Now we need the theoretical discharge, okay. Theoretical discharge, in theoretical discharge we have A1, A2 and square root of 2gs divided by A1 square minus A2 square. We will get A1, A2 because we know the diameter, D1 is 25 mm and D2 is 13 mm, okay. Using these formulas we will get A1, A2, and we know 2, and we know G is acceleration due to gravity, that is 9.81 meter per second square, and we have calculated H in meters of H2O. So if we subtract all these values, we will get Q theoretical discharge we will get through this formula. Actual discharge can be found using this formula, and CD can be found using Q actual by Q theoretical, right? So using this formula, if you calculate the values, we will getting the Q discharge, that is CD, coefficient of discharge is around 0.92 and 0.95. So thank you.